Assalamualaikum warahmatullahi wabarakatuh and good morning class.
Salam, sir.
Good morning, sir.
Okay, before we start, so we are going to have quiz 1. Quiz 1, so I plan to release the question on this Saturday. Don't worry, it is not fixed time. I will open the link from 8 a.m. Saturday until 5 p.m. So whenever you are free along that time, so you may log in to Kalam, okay, over here, week 3. Log into your Kalam and you may click the quiz, quiz 1. Okay, quiz 1. And then once you already start the quiz, you need to finish it in 15 minutes. So you cannot answer one and then one question and then you stop. No, cannot. Once you already start, you need to finish everything. So whenever you are free on Saturday between 8 a.m. to 5 p.m. Is it okay, class? Boleh tak?
Okay, sir.
Yang tak okay, ada tak? Anybody not okay? Ada? Semua okay Okay, so just a simple question. Starting covered from chapter 1 until chapter 3. 10 question and it is objective something like objective lah. Okay. Alright. So today saya tak share screen Today we are going to continue with sequential logic structure. Ni tadi saya tunjuk sini tadi kan kat kalam kan. Ni week 3. Okay, week 3. Can you see my screen, class? Boleh nampak tak?
Boleh.
Okay. Week 3 ni quiz. Okay, somewhere over here lah. So look at your section. Right. Okay, so to refresh So last week we covered sequential logic structure. As I mentioned, the element, the one that we discussed, which are the PAC, IC, IPO. These are used not only in sequential logic structure, in all program design. So we require these elements. And I already shows you the relationship between this. Okay, if you can recall that PAC, IC, IPO is mainly used for analysis, okay, problem analysis. Okay, so we want to gather the information related to input, processing, and also the outputs. So today we are going to continue with the rest of the elements. Okay. Right, so we are going to start with the pseudocode. Pseudocode. Pseudocode and algorithm lah. Don't get confused, class. Maybe before this, those who already took the computer science subjects during your foundation during your school time maybe you use the term pseudocode to represent algorithm something like that. Maybe you use different reference sometimes using different terms. Okay, sometimes this book use pseudocode, okay, to show exactly the algorithm. But in this class, okay, we use pseudocode to represent the design of our program in informal way. Okay, informal way. So if it is a formal way representing the computer design, we use algorithm. Okay, that's why over here informal way to explain the algorithms. Okay, so just remember this: pseudocode informal, algorithm formal. But in terms of standard way to construct, it is merely similar for pseudocode and algorithm. Okay, example of pseudocode. So this is an example of pseudocode. Okay, so pseudocode, as you see over here, it is a list of instruction to solve the task. So where do you see the list of instruction? Okay, the basic list of instruction we already done inside of the. Okay, if you still remember the IPO. Okay, where is the list of instruction in the IPO class? Which section? Which part of the table is the list of instruction?
Input and output.
List of instruction.
Processing.
Processing. Okay, processing. Okay, input and output also important over here, but it just shows the variables. Okay, related variables. Okay, this is variables. This is variables. Okay, recall back. This is the possible modules. Okay, that we can put in our design, and these are the list of instructions. Okay, so it is easy actually once you already have a concrete IPO. So your job or your task is going to be easier, okay, when it comes to constructing the pseudocode or algorithm. So what is pseudocode actually? So you just copy this everything over here. Okay, once let's say you are asked to design a pseudocode, okay, for a particular program. So just go back to your IPO, okay, copy the all the list inside of the processing column over here and put it in here. Okay, something like this. Okay, so you see over here. Okay, again, I say that don't get confused. Those already learned about pseudocode. So this is based on this reference. So other reference going to maybe have different way to develop the pseudocode. So pseudocode, you must have numbers, okay, and then the start. Start. Sometimes you put start, sometimes you put the pseudocode, the program name. It's up to you. It's up to you. It's okay. Okay, but this is for pseudocode. And you see that the process, okay, the instructions is listed in what we call in the correct flows of the program. So you cannot put read after calculating sales tax. For example, you put sales tax first before you read. So that is wrong. For example, like this. Okay, number 2. Okay, before you read, so you put calculate sales tax. So this is wrong, in terms of the sequence, the sequence. So wrong. Although all the instruction is presented in the pseudocode, however, the sequence is incorrect. So before you can calculate sales tax, you must have the value of price and sales tax rate first. Then you can do the calculation. So where do you get the value of price and sales tax? Okay, from the user by executing the input instructions first. Okay, so this is wrong. So make sure it is in a correct sequence. All right. And also make sure you are using the specific keywords, okay, for each of the process. Keyword something like this, read, input, enter. That one is keywords to represent the input process kan, input instruction. Okay, for example over here. Okay, specifically when a reader look at the pseudocode, they will know exactly this is a instruction for input. Okay, and the things over here, okay, pseudocode is mainly layman terms. It is using layman language, okay, which is we expect that everyone, okay, doesn't matter where they come, what are their background, computer science or non-computer science, literature students ke TESOL student kan, they when they read your pseudocode, they will know. That's why over here, in pseudocode, okay, we try to explain the process using language. Okay, as you can see over here, although this is actually a calculation kan, supposedly this is an equation, but we represent it. Okay, we represent the equation using text, using words. This means price of item times, times ni multiply. Okay, multiplication, multiply sales tax rate. But in pseudocode, we write it in English language that everyone can understand. Otherwise, we use star kan. So sometimes people don't understand what is star kan. People don't understand mode, for example. People don't understand integer division symbol. Not everyone can understand that. But if you put it in words, everyone can understand the meaning of this equation. Okay. Another thing is, you see that we are not using a formal variable. For example, price of item. So supposedly, formally we are using the names that is following the variable rules. Supposedly you cannot have a space. Okay, it should be understandable. Okay, cannot start with numbers. But over here is mainly a sentence. So what is it, the difference between pseudocode and algorithm? Okay. Algorithm is the same thing. Okay, the way you're representing your program design. Okay, but it is in a I put it algorithm over here. Okay, same thing. You copy and paste from the IPO. But over here, we start with normally we start with the program name. Program name. For example, this is to compute sales tax. Okay, so this program is used to calculate sales tax. Okay, we start with make sure it has numbers. Numbers, 1, 2, 3. You may start with 0, 1, 2, 3. Okay, it's up to you. Doesn't matter. Okay, let's say we start with 1 and then you put the name. Okay, the program name. Program name. And then okay, over here, okay, starting with the first instruction, we put an indent. Okay, indent. This is just to show a parenthesis. Because in parenthesis in programming is very important. Parenthesis. Nanti once we convert this into a program, you will see why is it very important. So this is to show the hierarchy. Okay, so this is a parent. Okay, this is what inside of the parent. Okay, this is a child lah. Okay, this is a parent instruction. This is resides within this parent. Okay, so everything, okay, all the instruction within the same indent. Indent ni ke kanan ni kan, ke kanan ni. Ini indent lah, indent. Ni indent satu, ni indent dua kali contoh kan. So everything within the same indent, okay, same indent, same level indent is in the same level. Okay, it is in the same level. Alright. So let's go to the instruction. So what's the difference between instruction from pseudocode and algorithm? See, this is algorithm. The difference is we are using formal kan. That's why we said algorithm is a formal way to represent program design. So formal is using formal variable. So let's say the variable that you use is price kan. So make it formal lah. Okay, price. Okay, or maybe you put price of item. You want to make it longer kan. So use underscore kan, of item for example. So follow the rules of naming variables. Okay, let's say I use price only kan. And then read sales tax. Okay, for example, this one read tax rate ke kan. Tax lah, tax rate. Tax rate. Rate lah. Rate kan. Okay, so rate, and then this is the text. For example, this is the text. Okay, saya malas nak tulis panjang kan, so I use a short form kan, but it is still understandable kan. So what's supposed to be the equation over here, class? Text equal to apa?
Price times rate.
Okay, price times rate n. Alright. Okay, correct. Okay, so over here supposed to be, let's say I use total kan, total. So price plus X. Okay. And print what class?
Total.
Print total kan. Right. Now it become algorithm. Very simple Okay, any question? Ada? Those who didn't yeah. Those who didn't have any computer science background, ada tak? Sometimes you have question kan, but maybe apa malu ke nak tanya, jangan malu lah kan. Tak ada masalah kan. Boleh tanya Simple question also boleh. Tak ada? Okay, boleh? Alright. If no, then let's look at the example over here. Alright, over here we have decision kan. So I just skip this first. Okay, this is next week. We are going to go to chapter 4, decision, and then we are going to discuss further on the this kind of pseudocode and algorithm lah that involve the decision and then looping. So I skip this first. Alright, so ni bolehlah baca sendiri So many, not only algorithm lah, algorithm and pseudocode. It is the same Algorithm and pseudocode is the same. It's how you write it. What's the difference? But the element inside of it, everything is the same. Alright, so this is important. Okay, please bear in mind if you have one case study, okay, and then you need to solve it. Student A may come out with algorithm 1. Okay, student B might come out with algorithm 2, and so on. So one problem, actually, you may design more than one algorithm to solve it. It is a matter how, it is not a matter of right or wrong kan. If it is right, it is right lah. If wrong, it's wrong lah. But the important thing is when you are designing a program, if let's say there are two algorithms and both produce the correct outputs, okay? So how can we determine which algorithm is the best? Kan? The algorithm that is shorter is the best because when your program have a shorter line of codes, it can execute much faster. So we are looking at the processing time. Okay, shorter meaning faster kan? Then it is the best. But in terms of correctness, if you are designing a longer problem, as long as it produces a correct output, still considered as correct. Okay, so that's why one problem can be solved by more than one algorithms. Okay, later on we are going to see some example. Okay, simple example. Okay. Okay, macam ni lah. Okay, this is equation. Ni kan, ni tak ada apa ni. Alright. So once we already completed, okay, the algorithms. Okay, once we already completed the algorithm, for example, this one. So this is missing line number. 1, 2, 3, 4, 5, 6. Okay, line number is very important. So how do you want to verify whether our design, okay, the algorithm is correct or wrong? So for that, we need to use dash checking. Okay, dash checking to verify our design. Alright, so dash checking. Okay, dash checking. Dash checking. If you want to develop it, you must follow this guideline. Okay. Okay. First, you must choose simple input test cases that are valid. Test cases ni apa kan? Test cases is the input lah, the input. Okay, for example, we have, okay, let's straight away go to example. Okay, if let's say we have this problem to calculate the area kan. So we already construct the algorithm. Okay, of course this is a simple algorithm kan. Once you look at the algorithm, you will know straight away that, oh, this is the correct algorithm kan. But imagine if you have 100 line of instructions kan, 1000 lines of instruction, how do you know that your algorithm is correct or not? Okay, it's quite tricky to if you just look at the algorithm kan without have appropriate tools for the checking kan. Okay, so first what you need to do is you must okay, the first one you must choose simple input test. Input test tu meaning that you just pick a random number lah to become the input. In this case, what is the input class? What's the variable for input in the algorithm?
Radius.
Okay, correct. Is area is a variable for input? Area. Is it input?
No.
No kan? So area is not input kan? Input, you look at the keyword. Okay, read radius kan? Or you may refer back to your IPO kan? Okay, refer back to the IPO and look at which one is the input kan? Ada tak yang area? Area. Tak ada Okay, look at this part over here. Okay, supposed to have area over here for example kan. Then it is input kan. So pick a random number for input. In this case only one. So easy lah. Just choose any any number, only one number kan. Sekejap Apa dah saya nak insert text kan? Oh ni. Alright. This one So let's pick up one number for the input, which is radius. So radius, let's say you choose one number, simple number kan. That's why it indicate over here simple kan. Don't choose a complicated input kan. 1 million ke 1,000 no kan. It's going to be harder for you to check kan. For example 2 kan. Okay. Okay, this part over here, let's say we use constant value 3.142. Okay, instead of pi kan. Okay, so what's next step to develop the dash checking? Establish expected result for each test cases. Okay, so for this process, it requires an expert lah, an expert for the program. Okay, expert can come from people that working in the particular area or the scope of your program lah. So you want to develop a program to calculate the sales tax kan. So the program for the computerized program is not there. So currently people use manual calculation to calculate tax, for example kan. So you go to the company and the company asks you to develop the program to calculate sales tax. Okay. So you go to the expert lah. You go to the maybe the accountant, okay. That will help you to establish the expected result for each test cases. Okay, because you yourself maybe not familiar kan with the calculation. For example kan, of course that one is very simple kan. Let's say we have a bigger problem kan. Okay, so you need to do this, okay? Establish expected result. Okay, you need to get the expected result from this input. Okay, but over here it is simple kan, simple problem. So you may get the expected result kan. Expected result is where you calculate the output manually. So in this case, what is the output class? The variable used for the output is
Area.
area. Okay, good. Okay, so over here we get the expected result. So this is the input. Okay, this is the input and then we get the expected result, which is the output kan. So from radius equal to 2, area equal to what? Equal to? Cuba kira. Berapa? Area equal to? Area equal to?
12.568.
Okay. 12.568. Okay, this is what we call as the expected result that we calculate manually. Manually ni lah. Alright. Okay, this is the second step. And then identify the relevant variables name within the algorithm. All the variables. Okay, all the variables. Not only for the input and output, but all the possible variables. So in this case, how many variables that we have? How many variables inside of the algorithm?
2.
Okay, 2 only, radius and area. So once you already identify this all the variable within your algorithms, then construct the dash checking table. Okay, the dash checking table consists of line number. So this line number should be tally with your algorithm line number. So if you have 5 line of instruction in your algorithm, your dash checking should have 5 numbers in the line number. Okay, if you have 10, this should be 10. It should be tally. Okay, so list down all the variables. Okay, each column for one variable. So if you have 10 variable, So you must have radius, area, and other 8 variables. List down everything. And at the end of your table, you should have this input. Right, input slash output. Okay, this is where we are going to put the details later on. Alright. Okay, that's step number 3. So test the algorithm line by line. Okay, so test the algorithm line by line, okay, keeping record of the content for each variable. So you act like you are a compiler. Okay, okay, compiler will read the program. Okay, once you run your program, the compiler will read line by line starting from line 1. So line 1 you read line 1 is nothing, just a algorithm name. So leave line 1 empty. And ada ni sini Okay, so this is a complete table. Okay. Okay, this one you already changed to 3.1. 3.142. Okay, and then line 2. Okay, line 2. So line 2 we have input radius. Okay, which is the value is 2 kan. Okay ni test data ni. The value is 2 for radius. So we put 2 over here. Okay, in the radius column over here, we put 2. And it is in line 2 Line 2 should be tally with the instruction. Line 2 If this is line 3, then make it in line 3 Okay, it should be in the same number, line number This is not just a number It is a line, algorithm line number. Okay, algorithm line number. Okay, but don't forget, okay, this is where we put radius and then tanda soal tu. Okay, and then put 2. So this, if you put it like this, it means that this process is input process. Okay, this is to differentiate between input and output process. For input, you must have this question kan? Question symbol ni, alright? And then, okay, moving to the next instruction in line 3. Okay, so in line 3 over here. Okay, in line 3, we have the calculation. Okay, so to do the calculations, okay, ni you guys nanti betulkan you do some correction to your lecture notes ni. So it's supposed to do the calculation Calculation, you want to get the value kan for the calculation. So over here, that's taking what we concern is the value, okay, not the variable that we use. Our main concern is what is the value, okay, the last value that we get. Is it tally with the expected result or not? That's our main concern. So that's why over here we must get the output over here Alright, over here. So do the calculation based on this equation. Okay, must insert the value in the variable. Okay, 2. Okay, multiply by 2. And then 3.142. So what is the answer? 12.568. Okay, 12. Okay. Alright. Is it input or output process? No, right? That's why you see this is empty. Okay, this is empty. Alright. Nothing over there. Because it is not input or output process. And in line 4, we have output process. Okay, print area. Alright, we are going to print the value of area. So what is the value of area? Okay, the value of area is over here, right? In line 3, we get the value of area, kan? So in line 4, we print the value. Okay, we are not printing over here, that's why it is empty. So this is process that couldn't be seen by user. User cannot see. It is internal process, kan? Internal inside of the CPU process. So user cannot see it. Okay, there's no input and output over here. So where user can see? Over here. Okay, so over here we put, okay, add area, area. Okay, area equal to 12.56x. Okay, this is to indicate this process in line 4 is an output process. So you see the difference between input and output? Input have this symbol, output use this symbol. That's how we differentiate. Okay? Now you can see that over here we have first set and second set. Okay, so this is the case if let's say the requirement asks you to construct two sets of test data, meaning that you need to running the testing 2 times, okay, just to verify the algorithm is correct or not. So you need to come up with 2 sets of test checking. So this is the first set, this is second set. That's why you see the number is reset again to 1 over here. 1, 2, 3, 4, 5. Okay, it is mainly the same process we use over here, but using different test data. Okay, this is using number 3, radius equal to 3. Okay, the input is 3. Okay, same. So make sure you change this. Okay, become like this. Okay, easy class. Boleh? Any question?
No, sir.
No, sir.
Okay, so once your algorithms, you produce an algorithm, much more complicated algorithm, you are going to have very long dash checking. Maybe up to more than 1 pages. Can be more than 1 pages. Okay, especially if you include decision and looping in your algorithm. So it's going to be quite challenging to do the dash checking. But for sequential logic structure, no problem. It just straight away, line by line checking. Okay, this is another example. Okay, another example to calculate the cube area ni kan. Okay, so make sure you have the test data. Okay, you have the test data and you calculate it manually to get the expected result before we proceed with the dash checking. Okay, and then construct the table for the dash checking. So list down all the variables, not only the inputs and the outputs, all the variables inside of your algorithm. So if you have 10 variables, so make sure you have 10 variables in the dash checking. If you have 100, then you must have 100 variables in the dash checking. Okay, and then check line by line. Okay, starting with line 1, then line 2. Okay, line 1, line 2, read H. Okay, read H. Okay, read H. Make sure if it is an input process, you put this symbol over here in the input and output column. And then in line 3, do the calculation using the real value of the variable. Okay, real value, not only the variable. So this is changed to apa? 69. Betul lah kan? 69. So correct 69. Okay. So make sure this This is to print. Okay, so this is very important, class. Let's say we have print area, and we want to print age, comma age. We want to print area and age in the same instruction, which is in instruction 4. You may have different instruction, print age one line, and then line number 5 we print area. You may do like that, or you may combine, kan? That's why you say that one program can have more than one algorithm, kan? So both is correct. Okay, but let's say if you put it like this, kan? Okay, so if you didn't put a proper way to represent the output, so you will get confused with the value over here, kan? So what is 69 for? Okay, and then what is the value for, kan? What do you need for? So this belongs to which variable, then? So you are going to get confused. That's why over here, make sure you put the variable name. So this is for area, okay, equal to 69. This is for age. Okay, you want to print age, this is we get the input for age. It's a different process, don't get confused. This is for input. This is to display. Input is user key in, user key in the value using your keyboard. User enter 4. User enter the value. This is user can view the value from the screen. User see, oh, age equal to 4. Okay, understand? So this is different if you put it in a different line. Okay, let's say over here. Okay, over here we put print age. Print age. So if you put it like this, wrong. Okay, so print age supposed to be in line number 5. Okay, this is a different way to do it. But both is correct, kan? Which one better? The one with less line number, kan? Boleh, kelas?
Boleh, sir.
Okay, same goes to input, kelas. So let's say if we have more than one input, kan? So you may combine, kan, in one line. As long as there's a condition, as long as the input should be in sequence. Okay, what do I mean by sequence, kan? For example, this is an example. First we have age, and then we have second age. Example, okay, so we have 2 inputs. Okay, if the sequence is apa nak panggil, back to back, back to back like this, kan? After user enter age, straight away user must enter age 2. Then you may combine in one line. Okay, so over here, okay, over here we should have another column. Okay. Kabut pula saya ni. Mana tadi? Okay. This is H. This is H2, H2. No. Faham lah kan? This is H, this is H2 Okay, this is H, this is H2. Because we have two H kan? H and H2. So in the same line, which is line number 2, we have two inputs. Okay, H and H2. So let's say H2 value is 2 kan? User enter 4 over here, user enter 2 over here. So it's supposed to be 2. And this supposed to have H2. What is the value that user enter? The user enter number 2. Alright, so this is acceptable. Okay, you may combine within the same line number. But let's say in the real world, in the manual process, okay, this is the computerized process that you design based on the manual process and let's say in the manual process, okay, without a computerized program, user must enter H, but straight away there's a calculation. Okay, before user can enter the value H2. Do you understand what I mean, class? Okay, before user can enter H2. So you cannot combine it over here because after read H, user must do the calculation first. And then user must enter H2. So you cannot put it like this. This means that straight away after read H, it will read H2. Wrong lah kan, input. Okay, so you cannot put it like that. If the situation is the input is not back to back. Okay, so instead of do like this, so you must do separately lah. Okay, separately lah. Okay, it must follow the correct sequence, right? Okay, so read H2. Okay, let's say if we have two inputs, but the input is not back-to-back process. Okay, after one input, there's calculation, and then there's another input, not back-to-back. So you cannot combine it in single line. Okay, so this is not supposed to be here lah. Okay, if this is the case, so in line 4, okay, line 4 you have input. Okay, line 4 over here you have input lah. Do you get what I mean, class? You understand this?
Faham, sir.
Any question? Ada? Tak ada? Boleh Okay, no question. Okay, this is another example. Okay, you see we have two inputs over here. Okay, two input, discount percent and price. Okay, so have a look at this. So in line 2, okay, line 2 we have input, discount percent and price. Okay, input, discount percent. Okay, in line 2, line 2 input, discount percent and price. Okay, so you may write down like this. Okay, so this is input for price, this is input for discount percent. Okay, the calculation in line 3 we have the calculation for the discount. In line 4 we have calculation for line 4 we have calculation for discount price. Okay, and finally we print the value of discount price in line number 5. Okay, print we use equal. Alright, okay. Okay, so that's checking. Okay, next. Okay, we are going to discuss on a flowchart. Okay. Okay, so it is either you are not required to develop a flowchart and algorithm at the same time when you are designing a program kan. So it is either you use flowchart or algorithm or pseudocode lah to design the details of instruction for your program. Okay, for pseudocode and algorithm is mainly using text to representing the program. But if you are more towards visualization, so you may choose flowchart to design your program. Okay, because flowchart is using specific symbols. Okay, it might be different from the mind mapping that you use during your school time kan. Mind mapping you can use whatever symbol kan for your mind map kan. But for computer science flowchart, we have a standard symbols that you need to use. You cannot use any symbol. You must use the standard flowchart symbol. So what are the standard flowchart symbol? Okay, these are, first we have flow lines. Okay, flow should be in one direction. One direction. There cannot be, okay, most of the time, in the flowchart, there cannot be two head flow line, two head arrow lah. For example, over here got arrow, over here got another arrow kan. Ini kan contoh example this one cannot two head arrow. Because in the flowchart, we must know the direction of the flow. Okay, either right to the right, to the left, up or down. Cannot both. Okay, so this is most of the time this is wrong. Okay, I'm saying most of the time, and there's also condition for that. And then we must have start and stop or exit. Okay, stop or exit if we have more than one modules. Okay, mostly we use start and end without if the program is non-module kan. Non-module kan, still remember what is module kan? Function we don't have a function, we will have this symbol, only two of it in our design. Okay, this one or you may use this shape as well. Okay, this one mostly we use this. It's not a complete circle this is what panggil apa benda ni, simbol ni namanya oval. Oval we use oval. So how we put as a start or end? So we put start over here and sometimes we put the program name over here. For example, calculate area. So we put calculate area over here. So there should be two of it. First start, and then at the end of your flowchart, you put end. Okay, and then we have line. So this is an empty flowchart. Okay, without any process Okay. And then we have processing. Okay, processing most of the time we use for calculation. Okay, if your program have any calculation inside of it, okay, for example, let's take this example. Mana tadi dah conteng pula Okay, radius let's say radius. Okay, so we have this calculation right. So since we have that calculation, so this calculation should be put inside of the rectangle. Right. Macam tu Ni tak ada input, tak ada output lah. Okay. And this also, okay, rectangle also can be used for initialization. Okay, initialization is something like this. For example, initialization. Pi equal to 3.142. Example. So over here we use pi kan. Okay, pi. So this is initialization. So most of the time, these two is, if it is presented in your design, so we put it in the rectangle shape. Okay, either calculation or initialization. Okay? So this is parallelogram for input or output. Both we use this. So how we differentiate which one is input and output if it is using the same symbol kan? Okay. Right. So how to differentiate? Okay. By using the keyword. Okay. For example, for radius kan? So we want to get the value of radius. So how do you know this is input output? You cannot know kan? If you just put radius and this symbol. We know that this symbol belongs to input and output process. But if you didn't put appropriate keyword inside of it, then people will get confused. So put the keyword lah. Let's say this is the input process, put enter. Okay, so people know this is input process. If this is a output process, you put the keyword for output lah, display or print, anything that representing output process. So this is output. Use the same symbol. Okay, let's say we use enter. So this is for input kan. Okay. And over here we have output. Jadi kan print area. Okay, so make sure you have this to guide reader of the correct flow. Okay, make sure you have this. So user know this is the flow. Okay, the flow is starting with start, go here, go here, go here, go here, and end. Okay, this is a complete flowchart lah. Sequence kan. Sequential is very easy, straightforward. Only one way from start to the end kan. There's no alternative way kan. So let's say we have alternative way. Let's come decision lah. Decision is use diamond. This is where we are going to discuss further next week. But just to show you that if let's say there's a decision, okay, there's a decision in your program. So we use this diamond symbol. Diamond. Okay, diamond symbol. Okay, along with the keywords lah, appropriate keyword. For example, the decision require if decision kan. Don't worry about this. We are going to discuss further next week. Just to show you example. If area less than 10, for example kan. So there should be only 2 arrow comes out from it, either true or false. Okay, either true or false. You cannot have third arrow. Okay, for decision, okay, you are only allowed to have 2 arrow. Okay, first arrow for true doesn't matter lah, left or right kan. You may put left, right, left true, right, false or the opposite doesn't matter as long as you label it. So it should be labeled over here. Ada true T T or F over here. You must write it down. So people will know that if true, if this condition is true, the decision is true, go here. If this decision is false, it goes here. Okay. So go where kan? This one you need to define lah. So go another process, input ke, calculation ke. Okay, that it should be something over here. You cannot left a flowchart hanging. So this is what we call it is hanging. No direction. Should go somewhere. For example, this one go here ke, this one go another way. Alright. Example, just a simple example. Okay, next module. Okay, so this is not the modules predefined modules. So please remember we have two modules, types of module. First predefined, which we get from compiler library. Okay, another one is user defined. Okay, user defined function, user defined module. So that one is the programmer do it kan. So this is for user defined module. Okay, we use this symbol. Okay, you may find it in Microsoft Word ada you may use the one in Microsoft Word. Also the same Okay, this is representing module. So let's say where we want to look at the list of module that we have class. In IC, PAC or IPO, where we can see all the modules that we have. Which one? IC, PAC or IPO? Ingat tak? Nak tanya lah. Alia, Nick Alia.
Yes, I use.
So where can we see the list of the modules inside of our program?
IPO.
Okay, betul salah satu. Okay, one of it is from the IPO So from the IPO, okay, over here we see all the modules that we have. So let's say we have 4 modules. So inside of our algorithm, okay, we draw 4 of this symbol For example, this first symbol is control Control is the main module Then we have calculate. Then we have read dulu read. Read, for example So we put somewhere in our flowchart. We must have this if we use module. Okay. So looping also we are not going to discuss it over here. Okay, I don't want you to get confused just yet. Okay. So later on, once we discuss the chapter looping, then we are going to talk about this. Okay, and then connectors. Okay, connectors is when let's say you have a very complicated flowchart and you cannot put it just in a top-down manners. Top-down from start until the end. You cannot expect to put end at the bottom of the page. So let's say that's the situation. It is a very long flowchart. So you may use connector. So there are 2 types, on page and off page. On page if the connection is in the same page. in the same page. So let's say this is a A4. Let's say this is A4. So this is where you write down your flowchart. And instead of, okay, this is correct. Let's say if you didn't use connector, so this one you just use this end, for example. Bukan macam ni kan. Dia sambung sini. Lepas tu dia ke sini Tak cantik lah. Do you know what I mean kan nanti ada yang silap pula faham kan. Saya guna line tambahan For example, it is like this Okay. So this is correct. Okay, this is in the same page. So you put it like this correct. But let's say if somehow make your flowchart messy so you don't want to get it messy there's over here and then this over here in the same page so you use connector use the connector. Okay, connector. Okay, connector. Hilang pula dia. Okay, this is a connector. So you put A over here, for example, this should be A lah. Okay, A. Let's say you have another connector over here. Say you have another one over here. It's B. So B is over here. Okay, B go to here, for example, and then continue to C. Okay, you can do that. This is in the same page. Okay, connection. Wireless wireless connection Okay, next is off-page connector. Okay, this is if we have more than one page. Okay, for example, this is one A4 this is another A4. Example lah ni paper kan. If paperless also can no problem the same concept Okay, this is A4, this is second page A4. So you want to connect the flowchart. Okay, it is very long, you don't want to make it in one page, you want to make it 2 page. So how to link between the first and second page? Use this symbol. But there, this is wrong The name should be similar. Let's say if you want to use A2, this should be A2 as well. If you use A2, A1, how do we want to connect Let's say if you have 10 pages, so you cannot use that. So use the same name for the connector. Okay? Boleh? Connector, alright. So that's it. Okay, for the basic of flowchart. Okay, especially for the sequential logic structure. The flowchart is very simple. Okay, this is another example. Let's say we have 3 inputs, length, width, and height. Okay, you may put it like this. Length, width, height. Enter, enter, enter. This is parallelogram. Representing input or output. But the keyword determine it is what process, input or output. So this is calculation using a rectangle. Okay, calculation, rectangle. Or if you have initialization, for example, length equal to 10, width equal to 100, initialization, not input. You must use this symbol as well. And finally, for the output, also parallelogram, but the keyword is representing output process. Okay, so can we combine this in one symbol? Can or not? Can we or cannot?
Can. Can.
Confirm, eh? Okay, so back to the rules lah. If the sequence is back to back, ni back to back lah. Kan, after length, width, and then height. Back to back. So you may combine all three in just a single symbol. Okay, single symbol. Boleh, eh? So how to write it? Koma je lah kan, koma. Koma. Combine. The rest delete lah. Ya. Sini eh. Same goes to the algorithm lah. So algorithm use comma lah. Comma width, comma height. Alright. This is another example. Okay, decision next week decision. Just an example lah, decision structure. Okay, this is looping. If looping, use the same symbol, but you can see a circle over here. This is not looping, sorry. This is still decision. Decision, you see the arrow, but this is to show you that the arrow can comes out anywhere. Okay, in the you can put it over here, you may put it over here, but limits to only two. Okay, two arrow, true or false. Over here still true, and then this is false then. Doesn't matter how you want to design, but make sure only two arrow comes out from a diamond, which is a condition or a decision. And for the looping, you see there's a circle over here. Okay, if you follow the arrow, you will get a circle. Okay, somewhere in your program you see a circle over here, indicating that this is a looping. Okay, repetition. Repeat until the condition is false, it goes out. Still two, true and false. No three. It must be two. You cannot have one. One, it will become infinity loop. If you have only one, let's say you forget to put false arrow, kan? So what will happen to your program? It will trap in the infinity loop. Doesn't stop. Okay, so if you have diamond symbol, make sure you have two arrow comes out from it. Comes in, it can have more than one come in. You can have 10 direction, 10 arrow comes in to the same direction. Do you get what I mean? For example, one, another one over here comes in. Berapa ni? 1, 2, 3, 4. 4 comes in. Doesn't matter how many arrow comes in, but the limitation is on what comes out. It should only be 2 arrow comes out from the condition symbol. Okay, doesn't matter whether this is decision or looping, it must have 2 comes out. Boleh kelas So we finish on the sequential logic structure. Okay, you may check out this later on by yourself, and also the case study. Okay, you may look at the case study. Okay, step by step. I think this is okay. This is not using a formal variable name, so you may use a formal variable name. Okay, class. Question. Okay, before you proceed with the lab exercise, so we have some question that require you to develop the flowchart and algorithm. So you may proceed with that and submit your exercise by tomorrow, before midnight. Okay?
Okay, sir.
Okay, sir.
Right, so if no question, then fill in the attendance. Okay, fill in the attendance and you may proceed with the exercise. Okay, thank you. Assalamualaikum.
Thank you, sir.
Waalaikumsalam. Thank you, sir.
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 Teacher.
Thank you, sir.